In this video, I'll be defining the hydraulic settings that are used for the land use feature definitions. The land use feature definitions are going to be grouped under the surface polygon category, and we're going to be creating a hydraulic prototype for each one of these. Going to the prototype dialog, I'll go down to surface polygon and create a new prototype. Rename that prototype, and then start defining the settings. So for the type, we'll set this to a land use. And then for the rational C value, I'm going to set that to user defined. And then I'm going to input that rational C value. So I can either refer to my spreadsheet or go up and look at my catchments and get the value from there. Next, I want to refer to this example of if you were going to first run the rational method and then later you decide you wanted to run unsteady state analysis and activate Civil Storm, what that process would look like. So here in my land uses, currently it's just using the rational method in this catchment, which is going to use that 0.9 value and the 0.36 value and then come up with that weighted value here, 0.706. But if we want to use a different method, then we're going to need to get one of these different values. And commonly this is what's used, the SES curve number. And so I have that set to a catalog, and right now I don't have anything in my catalog. So you have two options with the catalog. And I'll go ahead and open that up. Option 1 would be inside of the DGNLib. We would go ahead and include every single possible land use type. And then this library would already be pre-existing inside of the design file when they create their new drainage project. So their workflow would look like this if they would go up to their land cover type and then they would choose their soil type. Now this provides a very long list, and they're not going to have all these different soil types inside of their project. So I think probably a better method, instead of predefining this land cover catalog, I think a better workflow is to leave it empty, and then per project they can go in and import from the library just what they need. So for this example, I'm just going to bring in my pasture grassland, and then I'm also going to get my pavement. So now what I can do for these land uses is I can quickly go in and assign what type of soil that is. So that's going to be impervious. I'll say this is type B. And that's going to get me my curve number. And then I would do the same thing for all of the different land uses. And you could also do this in a flex table if you wanted to assign them in bulk. So this is going to be a pasture. I'll also do type B. And now if I go to my catchment that's using those land uses, and I'm going to change my method, so I'm using a unit hydrograph, and what this is going to do is calculate that composite runoff coefficient. So that's going to go in and read those two land uses, grab the curve number, and then give me a composite value. So going back to the DGNLib, when I set this up, I'm going to set this up to a catalog. And then if you're using these, you would set those up to a catalog as well. And then for the land cover type, I'm just going to leave that set to none. And I'm not going to configure anything for the land cover. So per project, they'll go in, import from this library that's available whatever they need for their project. And that's going to limit this drop-down menu to just the soil type and land cover types that they're using in that project. So I'll continue creating a surface polygon hydraulic prototype for each one of these feature definitions. And then I've assigned those prototypes to each of those feature definitions. Now one last setting on the prototype, I'm just going to leave the priority set to 0, which is going to either do lowest or automatic. And this comes into play if you have two land uses that overlap one another, which one is going to be priority. So if there is a preference there, you could set that priority. Otherwise, you're just going to want to leave that set to the auto.